Any questions from homework? You guys, everybody knows there's homework, right? Especially those of you who signed up for WebAssign. You guys realize you signed up and there's stuff to do in there? Okay. Just want to make sure you guys know. Even if you didn't, there's a book with problems, right? Okay, I like it. Tomorrow I'll have all the homework turned back to you that you've turned in so far. I just have had a million other things to do first. I like to get it done for you in time so you can look at it for the test. So I'll have it all back to you. I haven't given it back to you yet. Okay, no questions on homework stuff? All right. A quick little review of a couple things, and then I've got a little handout, and I'll let you guys work on together for some practice. Let's see. What was the derivative of natural log of x? 1 over x. Real quick, there's something kind of interesting about this statement I just made. Who remembers what's the domain of the natural log? Yeah, x greater than 0. If you think about the picture, which you should have stored in your head, here's what natural log looks like. There's an asymptote here, because there's an asymptote here for the exponential, and this is the inverse of that. So x has to be greater than 0. What's the domain for this guy? Everything except 0, meaning it could be negative stuff too. So to make this a more complete statement, I know some of you guys do. All right. Do you guys understand the inherent problem here? I'm saying that this function's derivative is equal to this other function. They have different domains. It doesn't make any sense. So later we're going to be undoing the differentiation. When I do that, when I take the antiderivative of this, I have to write natural log of absolute value of x to cover my ass in case x is negative. Now obviously, you don't have to do a if I ask you what's the derivative of natural log of 3x, you don't have to introduce absolute values when they're not there. But this rule is now a little more general if I put absolute value in there. Is that cool? But still, how would you do this guy's derivative? What rule do you have to use? Chain rule. What's the derivative of ln of something? 1 over that thing times, yeah, the derivative of the inside, which is 3. What happens here? All right, so you don't have to introduce the absolute value with derivatives, but when you do an underderivative, antiderivative, you have to cover your ass for what could have been there. You don't know. We'll see that, obviously, when we get to the antiderivative stuff. I like it. Some of you guys are like, don't talk about the opposite of something. I don't even understand the thing in the first place. Okay. It's coming, though. I'll let you. What else have we done recently? Well, there's a whole chain rule thing, but that's a little too broad. What's this? Let me give this to you in a little different way. What's this? So however you like to memorize things, you need to do that, right? Every derivative we know so far, you must know. Thursday, they're going to be there. I'm not going to let you use a table of derivatives or whatever bullshit. You just got to know them. Yeah, so who's got this? I think I heard it. Secant squared. Secant squared. I like it. So this is not something that's immediately obvious, just staring at tangent. If you really, really needed to, if you forgot, you can write sine over cosine and use quotient rule to rederive it. I'd rather not. I'd rather just kind of memorize this, right? There are a few things you just have to straight up memorize. Or you do it the long-ass way if you forgot it, right? So then what's the derivative of cotangent? Co. Derivative of any co is negative something. So it's negative cosecant squared. I mean, do you see how that's a beautiful, Why am I negative so big? It's a nice symmetry there, right? Remember, here's a really freaky one. This is a freaky one, and sometimes that makes it easier to remember. What's the derivative of secant? That's the one that's got like somehow it repeats itself and then it brings somebody else along. Secant tangent, right? Secant x, tangent x. So then what's the derivative of? Make a little 5j. Cosecant. Negative. Cosecant. Cotangent. I mean, do you see how you really have to memorize 3 of these things? 3 of the things? And the other 3 just kind of mimic those.
So there's going to be questions on the test to ask you what the derivative of those are, and we just have to know what it is.
Totally. Yes.
And so we don't have to write out any word for it, we just have to write what it is.
Yeah, exactly. Totally. If I ask you, if I say, what's the derivative of tangent x, I really don't want to see any work. If you have to write it as sine over cosine and do it, I'm not going to take points off. I'm going to put a little down and say, you probably want to memorize that shit. Right? Now, obviously, I could give you this kind of problem. What's the derivative of tangent of natural log of x? Well, yeah, chain rule. We have a function inside of a function, so you forget about the ln of x at first. You just worry about the fact that it's tangent of something. What's the derivative of tangent of something? Secant squared of that thing. Then you multiply by, good, the derivative of the inside. You just write the rule out real quick. So it's secant squared ln x times 1 over x. And you just bring it underneath the secant squared if you want to, the x. Is that cool? Or understood? Maybe cool is too big of a push. Okay. Let me think. And what else is recently? We did quotient rule. Let's do a quick quotient rule. Let's just look at the rules we've got so far. We just got these first 3, right? So what is quotient rule? If I had to do this, what's the rule say? What's the song? The song is top first. Sorry. I'm just making fun of so many flipping songs and bullshit. Top first, right? So the derivative of the top, I'm going to write the rule out just to have the form of it sitting there and staring us in the face. Top derivative first times the bottom. I love it. It feels a lot like product rule, but there's a minus here. Why does that minus make sense? Because when it was on the bottom, it's going to have a negative power. Totally makes sense, right? I need some song to tell me what the shit to do. Songs don't tell me what to do. Sorry. Yeah, leave the top alone, derivative of the bottom. All over. Bottom squared, which comes from the LCD we would have to do if I did make this into a product instead of a quotient, right? So there's a lot of ways to make it just make sense why the rule is the way it is. I hate making students feel like we need songs to know anything. Some of my colleagues disagree with me, and then I don't feel like being wrong. So what's this guy's derivative? 2x, and then I can distribute it. What's this guy's derivative? 1. Sweet. So I can just distribute the minus. And then over this thing square. So then you get x squared plus 10x minus plus 1 over x plus 5 squared. Sometimes it might cancel something here, but obviously this one. I like it. Cool. Appreciate quotient rule. Don't necessarily. I'm not saying. Now, some of you, if you wanted to, you could bring this up, make it a product. No problem. You could be like I used to do. Quotient's not horrible. I think it's because my instructor didn't really explain to us. I'm not saying that I'm amazing, but I'm just like, nobody showed me why this minus makes sense where it is. So I couldn't remember which one of these went first, and I kept losing points. I'm like, screw that. I'm just going to bring this dumb thing up. Do it that way. I don't have to remember which goes first then, right? If it's a product rule, it doesn't matter which goes first. It's addition. Here's subtractions. Go throw the whole damn thing to shit. You guys. All right. So if you want to, you can. All right. I think that's pretty much everything we've done so far, in a way. Yeah. Oh, here. What's this guy? What Roman numeral? I have no idea. What's the derivative of 7 to the x? Yes, it's what's the derivative of e to the x? E to the x. Anything else is itself times an adjustment, and the adjustment is the natural log of the base. That's how much off it is. Let me see. How can I? Yeah, that would work. Real quick. See, I'm trying to make something up on the fly. I don't know what that is, right? So can't I take ln of both sides? Bring the x down. Right? Is that cool? And then can't I raise e to both sides? I think I'm just doing this along. That's right. Is this the way we did it? I think this is the way we did it. Yeah, we just rewrote that as that. That's another explanation why this, I can rewrite 7 to the x as e to the x natural log 7. If I take this guy's derivative, I take the derivative of both sides, it's itself times the derivative of the inside. And of course, this was 7 to the x. So I like to think e to the x is perfectly its own slope. E to the x's derivative is e to the x, which means the function itself tells you the slope at that point. So what's the slope of e to the x at the point 1? E, because it's its own derivative. It's crazy. And it's its own second derivative. It's its own third derivative. It's its own 80 millionth derivative. Holy shit. Anything that doesn't have e as a base, the shape of the curve is not right to match up with their slope. It's offset by this multiple. Natural log of the base. That's how off it is from being its own slope. E is the one that kind of perfectly lined up with what its slope would be. Okay, that's enough of that. What's up? Everybody all right? I think we sort of proved it doing it this way. Okay. Oh, one last thing before I give you this handout. Is there any difference between this and this? I think we talked about this before. I can't remember. Oh, hell yeah. Which one of them can you actually do something with? No, not really. I mean, what do I mean by that? Like this, you could write it 7 times. Can you do anything with that? No. This, I could do something with it. There's a property of logarithms. I could rewrite this in a much better way. Do you remember what that is? Okay, well. How do you solve, I almost said a problem like Maria, but how do you solve this? Solve that. Solve it. Without a calculator. Do it now. Do it. Solve it. If anybody's divided by 11, I'm going to have to take a real quick cry somewhere. Tell me, you've already done enough to make my point up here. What is the first step in solving this? Somebody just say, I know you guys don't like to talk. Somebody say, what's the first step? What'd you do? What's the first step to do to solve that? Yeah, you can take any log you want to, but natural log is a good one because it's got one less letter than others, right? So that is the reason why we do that. Doesn't matter what log you use, because what would you do next? The power comes, that's a, okay, how do we write this? 7 ln x. I mean, that's, right? You know how to solve that because you know the property lets you take that down and then you can divide by ln 11, right? There's the exact answer. You can throw it in the calculator and get an approximation. So of course I can do the same thing. Anytime this inside is being raised to a power, I can bring it down. Logs are powers, so every property of logarithms is a property of powers. What do I do when I raise something with a base that's being raised to another power? So let me say this again. If I have a base being raised to something and I raise it to another power, what do I do with the two powers? Like if I had x squared to the 4th. Multiply them. Multiply the powers. ln is the power on e to make x, and I'm raising it to 7th. So of course I multiply the damn two powers, right? Every property of logs is a property of powers because logs are powers, right? I'm not going to reteach you logarithms, but I just want to say that. Okay, let me give you this. There is a side 1 and there's a side 2. So only look at side 1 for right now. Side 2 is stuff we haven't talked about yet.
Is it one paper per group?
Huh?
Is it one paper per group?
No, again, everybody piece. And then I do want you guys to, I'm going to force you to do this. Find at least one other person, if not two, to group up with. You hate to do that, man bad. Find somebody else that hates it, just turn in chairs and pretend like you're home. Pretend like you're working together. Side 1, it says differentiation practice. Don't do implicit differentiation practice.